now let us talk about entity types and entity sets. Entity type is a collection of entities that have same attributes. For example, if I define an entity employee by the attributes name, age and salary, so employee is then an entity type, or you can take it as a heading, okay, or the schema. So employee is an entity type, or we can say the collection of all entities that have the same attributes. Let me write it. Entity type, collection of entities that have same attributes. Okay, so it can be represented, or it is represented by writing the name of the entity followed by the set of attributes, okay, that is used to define that entity. For example, employee, name, age, salary. So employee is an entity type, or we can say it as the heading. Next thing that we are going to talk about is entity set. An entity set is a collection of entities of a particular entity type at a particular time in the database. Okay, so entity, what is the difference between entity type and entity set? Entity set is a collection of entities at a particular time in the database, and entity type is the collection of entities that have same attributes. I will give an example after which it will be clear. Let me write the definition first. Entity set is collection of entities of a particular entity type. Particular entity type in the database at any time. Okay, so both the entity set and entity type is represented by the same name, employee. Employee represents the entity type, that is the collection of entities, as well as it also represents the set of entities that are present in the database at any time. Okay, let me show it, write it and show it. Let us say employee, name, age, salary. Now, if I have an employee E1 who has name as John and age as 30 and salary as, let us say, 40,000, or we have an employee E2, Ravi, age is 40 and salary is 30,000. Now that is pretty much the information that is present in the database at this point of time. So this is called as the entity set, and this is called as entity type. Employee is the entity type and this is the entity set. However, the name employee is used to represent both the entity type and entity set. Okay, so that is about entity type and entity set. Also, entity type is called as intention and entity set is called as extension. Okay, so this is called as intention and entity set is also called as extension. Right, now we will see how to represent entity in the ER model, in the ER diagram. Now, an entity in ER model is represented by a rectangular box like this, right? If I want to represent attribute, what is an attribute? An attribute is the property of entity. We studied in the previous this video, right? So attribute is represented like this, like an oval, right? So let us say we have an employee entity, and this employee entity has attributes name, age and salary. Okay, so then we will represent an ER model as employee, and employee is an entity and it has attributes name, age and salary. Alright, so this is how we represent entity and attributes in an ER model or the ER diagram. Right? So now let us see what are the key attributes. So usually an entity type will have an attribute which is used to identify each entity uniquely or each entity of the entity type uniquely. So a key attribute is an attribute whose values are distinct for each individual entity. For example, let us say employee has a social security number, which is a unique number, and for every employee there will be a unique number. So if you want to identify an employee, it can be identified by specifying the social security number. So social security number will be called as a key attribute. Or let us say if we have a student entity, then the student roll number has to be unique, or let us say student admission number has to be unique. So using the admission number we can identify each student uniquely. So admission number is called as a key attribute. Okay, so an entity can have one key attribute or more than one key attributes, or it may not have any key attribute. If an entity does not have any key attribute, then it is called as weak entity. And if an entity has a key attribute, then it is called as a strong entity or regular entity. Right? Let me write it. So in this course, I may use entity and entity type interchangeably. So whatever is the concept, you can understand accordingly, right? So let me write. It is actually weak entity type. Weak entity type. It does not have any key attribute. And strong entity type. It has a key attribute. One or more key attributes. So sometimes what happens is we might not have a key for a particular entity, or we cannot have one attribute which identifies each entity uniquely, but there can be a combination of attributes which can be used to identify each entity uniquely. In that case, the combination of those attributes will be designated as the key of the entity. So in that case as well, it will be called as a strong entity. Weak entity type is the one in which even all the combination of attributes taken together are not able to identify each entity uniquely. In that case, it is called as a weak entity type. In case of strong entity type, it can either have one or more key attributes, or combination of attributes can form a key, or it can be used to identify each entity uniquely. Okay, so that is about weak entity type and strong entity type. Now we talk about value set or domain of the attribute. But before talking about that, I just wanted to specify that the key attribute or the uniqueness constraint is not a property of a particular extension. It is a property of the entity type itself, which means that if I write if I have two employees whose social security number is something. Now social security number can be used to identify each employee uniquely. But even if I add more employees, this property should hold. That is, SSN should be able to identify each employee uniquely. Okay. So key constraint, uniqueness constraint or key attribute is of the entity type, that is the entity type employee. If the student has a unique admission number, then for every student, or every student will have a unique admission number, and it is not the case that just for some few students there will be a unique admission number and after that some students will not have the unique admission number. So the student entity type, if it has been given that the key attribute is admission number, then it will be unique for every student, okay, so, or for every instance of the student entity type. So that is about the uniqueness constraint or key attributes. Now let us talk about value set or domain. So what is the value set or domain of an attribute? It is the set of values that a particular attribute can take for each individual entity. For example, if I say that in the company or in our company, the employee's age cannot be below 16 or above 70, then the range of age attribute has to be between 16 and 70. So we specify the domain or the value set of age attribute to be the set of integers between 16 and 70. Right, so that is about the value set or domain of the attribute. So should I write it? Value set or domain. Set of values that an attribute can take for each individual entity. So just like how we have entity type, entity set, similarly we have relationship type, relationship instance and relationship set. So entity can be similar to relationship instance. Entity type and relationship type. It means that you can compare them. They compare their relationship. Entity type is a collection of entities. Relationship type is a collection of relationship instances. Right? And then the next thing is entity set and relationship set. So like entity set is a collection of entities at a particular time in the database. Similarly, relationship is a collection of relationship instances at a particular time in the database, right? So these are comparable terms. So each relationship instance associates one entity, exactly one entity from each of the participating entity type. So let us just take an example, then it will be more clear. What is all this? Or how are we going to do this? So let us say the company specifies that an employee works for a department and many employees can work for one department, but there is a new department which may not have any employees. So right, so let us say in this kind of diagram, employee. So employee is an entity, department is an entity. Is it visible? Department. And this one is the relationship works for. Right. So there are employees and there are departments. Or let us say there cannot exist a department without an employee. So every department has some employees working for it. So what is a relationship instance? E1 is an entity and these are relationship instances, right? A relationship type is a collection of relationship instances, right? So this particular one instance relates exactly one entity from this and one entity from this. Employee works for E1. Now E2, let us say E2 works for department D2. E3 also works for department D1. Now I cannot make E1 join to this and this joining to D1, because every relationship instance has to connect exactly one entity from each participating entity type. So what are the participating entity types for works for relationship? The participating entity types are employee and department, right? So employee and department are the participating entity types. So each relationship instance can contain just one entity from each of the participating entity types. Now let us say E4 works for D3, E5 works for D3, E6 works for D4, and E7 works for D3. Right, so this is the kind of relationship. So let us say, let us define more terms. Let us say cardinality ratio. So cardinality ratio is the maximum number of relationship instances in which an entity can participate. So how many relationship instances each entity can participate here? So E1 can participate in only one relationship instance. See, E1 can participate in only one relationship instance. E2 can also participate in one relationship instance. E3, E4, E5, E6, E7 all can participate in only one relationship instance. So the cardinality ratio of employee entity type is 1. Okay. Now, D1 can participate in how many relationship instances? It can participate in 2 relationship instances. D3 has participated in 3 relationship instances. D4 has participated in 1 relationship instance. So since there is not a fixed number and each department can participate in many relationship instances, so we represent it by N. Okay, so N, a department can participate in N relationship instances and an employee can participate in only 1 relationship instance. That is the cardinality ratio. But when we want to represent this relationship, employees to department, we cross-change it. Employee is to department is N is to 1. Cardinality ratio. Why? It means that a department can have many employees. Okay, a department can have many employees, but an employee can have only 1 department. Okay, so employee cannot have many departments. If an employee could also have many departments, or it could participate in many relationship instances, then here it would be M, and then when we cross or we exchange it, here it would be M. But what is the case here? An employee can participate in the at most 1 relationship instance, so it is 1. Okay, so a department can have many employees, but an employee can have just 1 department, and it cannot have many departments. That is the meaning of cardinality ratio. Next we talk about participation. Participation constraint. So, like participation constraint means the minimum number of relationship instances in which an entity can participate. So, this is the maximum number of relationship instances and this is the minimum number of relationship instances in which an entity can participate. So, E1 can participate in minimum how many relationship instances? It has also been given that an employee cannot exist without a department. If there is an employee, then definitely he has to work for a department, so this is the constraint that has been specified in the requirement, that an employee cannot exist without a department. An employee has to definitely work for a department. So it means that every employee has to work for a department, so every employee has to participate in 1 relationship instance. So the participation constraint is 1, or the participation constraint is 1, that is minimum number of relationship instances in which employee entity type participates. Now, if it has also been given that there cannot exist a department without at least 1 employee, then it also has to participate in the relationship, which means that every department should have at least 1 employee. That is, every department participates in at least 1 relationship instance. So it gives at least how many relationship instances, and this gives at most how many relationship instances in which the entity can participate. So that is about cardinality ratio and participation constraint, and these two together are also called as structural constraints, right? So that is about cardinality ratio and participation constraint. Also, one other thing I wanted to discuss, that is degree of a relationship or degree of a relationship type. Degree of a relationship type. Degree of a relationship type is the number of participating entity type. Now, let us say works for relationship has two participating entity types, employee and department. Okay, so it is called as a binary relationship. What it is called? Binary relationship. Sometimes there can also exist a relationship in which there are more than two participating entity types. In that case, if it has three participating entity types, then it is called as a ternary relationship type. So this one is called as a binary relationship type. That is called as a degree of a relationship type. So that was about it for this particular video. I hope you like this, and please press the like button